Okay, so good afternoon, good evening, good morning, whatever time you're watching this. So it's engineering with Trish once here. Today's presentation is a very short or brief one. It's still on the refrigeration cycle, but then today I'll be addressing students' questions. So I've titled this Students' Questions Series 1. Now, in this lesson, I will quickly recap the refrigeration process, and then the questions are actually four. I saw four questions in the comments, which I intend to address today. The first question is from Ebenezer, and he said, Madam, how can the refrigerator remove heat? Second question is from Zadok, and he asked, how do engineers choose the refrigerants when considering both efficiency and environmental impact? And then the last two are from Frederick. The first one is, what do the blue and red colors symbolize in the diagram? And then the second is, what is the purpose of the expansion valve? So that is why we are having today's presentation. So quickly, I will recap the refrigeration cycle, that is the components. So we mentioned that there are four main components, and these components, you can see them here. That is the compressor, the condenser, the expansion valve, and the evaporator. These are the four main components of the refrigeration cycle. So that is our compressor here, our condenser, the expansion valve or the throttling device, and the evaporator. So I mentioned it before that we have two heat exchangers. This is the evaporator and the condenser. And then we have the compressor and the expansion valve. So these are the four main or major components of the refrigeration cycle. Now, to answer the question about how refrigerator removes heat, I will use the sachet water, what we call pure water scenario. So basically, let's assume you have water, sachet of water at room temperature, I think between 26 to 32 degrees Celsius, let's say 26 degrees Celsius, for instance. You open your fridge or refrigerator, you put the sachet of water there, you go and come back the next 30 minutes as assuming, and then you realize the temperature is no longer 26, but it's 20. You know, so what happened? So to help us understand this, I'll take us through all the components functions. So the first is that as soon as you open the fridge and put the sachet of water in fact, if it's an air conditioner, you always realize that what the compressor starts running. So most authors say the process starts from the compressor. So the compressor sucks the refrigerants from the evaporator at a lower pressure, lower temperature. And then the compression process what increases the temperature and pressure of the refrigerant. Compression means the refrigerant is squeezed. So by so doing, the volume reduces and the pressure and temperature will go up. That is the compression process. Now, when this happens, the refrigerant changes phase. In fact, we say superheated refrigerant. So this superheated vapor leaves the compressor and goes into the condenser. The condenser, like we know, is what? A heat exchanger, which means that the temperature of the refrigerant now is very high compared to the environment. So the heat will spontaneously flow from the condenser to the environment, where it will make what? Little or no difference. Now, after the heat is exchanged, the refrigerant now is at what? A lower temperature. So this low temperature, of course, the pressure is not so low because the condenser is a heat exchanger. The pressure is still there, then it goes into the expansion device for the throttling valve. So here, the expansion device is what? It behaves like the brain or the mind. It thinks for the system. So according to the number of sachet water you have in the fridge, it throttles the refrigerant flow. It throttles, so it regulates the refrigerant flow. And then this refrigerant now, because of as soon as it passes through the expansion device, the pressure drops instantly. So now the pressure is less, the temperature is less, and this refrigerant goes into the evaporator. So what happens? The sachet of water is at 26 degrees Celsius, remember. which means that because the refrigerant now in the evaporator is at a lower temperature, then the heat will flow from the sachet of water to the evaporator. The evaporator cools. So what happens? This heat from the sachet of water actually boils the refrigerant. So the boiling will change the phase. The boiling will change the phase. So we will say the refrigerant is what vaporizes. So the phase changes to vapor. I don't want to go to the saturated and those things yet. So it goes into the vapor phase, and then this refrigerant is sucked by the compressor again for the process to continue. So so let's say the first one, it takes let's say 5 degrees of heat is taken from the sachet water, it goes and comes again. See, so if the cycle continues, it means the refrigerant, the temperature inside the refrigerator and the sachet water will attain what equilibrium if the process continues. So definitely you come and take your water very chilled now, and then you can enjoy it. So that is just how the refrigeration cycle works. Now, what absorbs the heat? So I think I explained that the evaporator, it is always in the refrigerated space. So for our fridges, we see this kind of evaporator here, the plate type, as we can see on the right, that is the evaporator. So the refrigerant is at a low temperature and pressure. And like we said in the second law of thermodynamics, heat flows from a warm space to the cold refrigerant. The sachet of water is at 26. Let's say inside the fridge is 10 degrees, so the heat will definitely flow there. Then the refrigerant evaporates, phase changes, and then this creates the cooling effect. So the next question was, how do engineers choose refrigerants? This one is a whole topic on its own, but I'll just answer it briefly. So refrigerants, like I said, they are specially made fluids for what? Refrigeration systems. So first, they consider the thermodynamic performance, like the boiling points. For instance, the refrigerant should boil, but it should have a low boiling point. I just said sachet of water heat is not enough, but that should be able to boil the refrigerant. Look at the latent heat and some other properties. This is a topic I will discuss later. They also look at the environmental impact of the refrigerant. A refrigerant should have a low global warming potential and zero ozone depletion potential. Why? When there is a leak, you will not see it. It is only when the system starts acting funny, like the cooling is not as it used to be, that is when you know there is a leak. But then it goes into the environment, and then it also leaks into our room. So it should be safe, because you don't want you to inhale refrigerants and pass out. Do you understand? It should also be what? Non-flammable. You don't want the case somebody is charging the refrigerant, that's a standard topic for another day, and then boom, we see explosion. And then it should be cheap and readily available. So these are some of the properties the engineers consider before they choose refrigerants. Some examples of refrigerants. So the common ones are we have R134A, we have R600A, and so on and so forth. But now the most common one is R134. Even that it is being phased out soon. Then we have R290, which is natural but flammable. So the choice of refrigerants actually depends on the application and safety requirements. So the next question was, what is the expansion valve? I think I've mentioned that when I spoke about all the components, but then the expansion valve, like I said, is the brain or the mind of the system. It thinks for the system. You understand? Okay. So first, it controls refrigerant flow. In fact, if you go home, you can check what is behind refrigerators. They're usually the capillary tube. You see, they are just like some coils. So you check and then you let me know. Then by that, what happens? The pressure drops suddenly, and this causes what? Temperature drop, and then this prepares refrigerants for the evaporation process. The important thing is that we say refrigerant is what's throttled. Another name for the expansion device is what? The throttling device, because it regulates or meters the flow of refrigerant before it goes into the evaporator for the evaporation process to be what? Complete. So refrigerant enters the evaporator as a low pressure mixture. Then the last question was about the meaning of the colors I used. So when you see red, usually it stands for hot region, high temperature, high pressure, heat energy. When you see blue, cold region, low temperature, low pressure. And then this is just to show us that what we are moving heat from a cold space and releasing that heat to a warmer environment, which is what the fundamental principle of refrigeration. So I hope I've answered your question. So in summary, We are saying that the evaporator absorbs heat that causes the cooling effect. That is how your sachet of water got chilled or cold. We are saying refrigerants are chosen based on their peculiar properties. So usually performance is one of them, environmental impact is one of them, safety is also one other. Then the expansion valve enables the cooling cycle. It thinks for the system. The red color usually denotes high temperature or pressure, and the blue colors denote low temperature or pressure. So it's your turn now. Share one key thing you've learned from today's lesson. Ask one question you want explained, and then please you try to constructively reply to your colleague's comment as well. Who knows, your question could be featured in the next video. So until I come your time again, let's keep learning. And this is Engineering with Trish. Please subscribe, please like my video, and the next lesson will go to the mechanical vapor compression system. So thank you so much for watching today's video. It's bye-bye for now. Shalom.